The story of Pisco Monster Sea. If you stand in the middle of Peru's Pisco Desert today, you see a silent, lifeless land. Dust, sun, and stillness. More like Mars than a coastline. But geology is a time machine, and the rocks beneath this desert record a very different world. Turn the clock back about 12 to 13 million years into the Miocene Epoch. Erase the desert and replace it with a dark, nutrient-rich sea. This was the Pisco Formation, one of the most remarkable marine fossil sites on Earth. Paleontologists call it a kind of marine graveyard because the fossils are so abundant. For decades, teams uncovered whales, dolphins, seabirds, sharks, and many other marine animals here. Then in 2008, a field trip produced a discovery that changed the story. Researcher Klaus Post spotted a massive skull protruding from the sediments of the Pisco Formation. The skull was about 3 meters long, bigger than almost anyone expected. At first, it looked like it might belong to a large whale, but as the rock was cleared away, something stood out immediately. Teeth, not small teeth for catching squid. These were thick conical teeth built for power. The original description reported teeth up to about 36 centimeters long and roughly 12 centimeters wide. The team named the animal Livyatan melvillei, a nod to Leviathan and to the author Herman Melville. Livyatan created a big question. How could an ecosystem support more than one top predator of similar size? Because the same sediments also preserve evidence of another giant, Otodus megalodon. Fossils of both animals appear in the same formation, meaning they overlapped in time and place. So this coastline may have hosted two huge hunters in one productive sea. That raises the next question. What kind of environment could feed them both? In the Miocene, Earth's climate was changing and ocean currents were shifting. Along Peru, winds helped drive upwelling, cold, nutrient-rich water rising from depth. Those nutrients fueled plankton blooms on a massive scale. Plankton fed small fish, and small fish fed larger fish. And that energy supported a boom in medium-sized whales. Many of these whales were smaller than modern giants, roughly a few meters long, but extremely abundant. And in colder water, whales carried thick blubber, one of the most energy-dense tissues in nature. In other words, this coastline offered enormous energy packages moving through the sea. Let's start with the predator most people recognize, Megalodon. A pop culture often shows it as an oversized great white, but scientists debate its exact body shape. Most research places it among the megatooth sharks in the family Otodontidae. Estimates often put adult lengths around 15 to 18 meters, making it a true ocean giant. A body that large demands constant energy intake. Its teeth were broad, triangular, and serrated, built for efficient cutting. Fossil whale bones around the world preserve bite marks, consistent with large serrated shark teeth. That evidence suggests Megalodon targeted whales as a major food source. Its advantage was mechanical efficiency, speed, mass, and a cutting toolkit. Bite force estimates vary by method, but the main takeaway is clear. It was among the strongest known. In a rich sea full of whales, that design could thrive if food stayed plentiful. Now meet its rival in the same waters, Livyatan melvillei, a raptorial sperm whale. Unlike modern sperm whales that specialize in deep-water squid, Livyatan had teeth in both jaws. Its teeth were thick, conical, and built to grip and hold large prey. But Livyatan's most unique tool wasn't only its teeth, it was its head. Sperm whales are known for advanced sound-based sensing, and Livyatan likely used powerful acoustic perception too. In ocean water, sound travels fast, making acoustics a major advantage in murky conditions. That means Livyatan could detect large animals at distance, not only by sight, and because it was a mammal, it may also have had higher problem-solving capacity than most sharks. Modern toothed whales often live socially, which can support coordination and teaching. So in one productive sea, could two very different designs converge on the same fuel source? Whales. One was optimized for cutting power, the other for gripping strength and advanced sensing. In nature, top predators often avoid direct confrontation because injuries carry long-term costs. So the most likely outcome is competition through territory, timing, and opportunity, not constant battles. But overlap also means moments of high tension, especially when food becomes scarce. And if either predator targeted juveniles of large species, conflict risk could rise. The Pisco Formation captures an ecosystem dense enough to make that overlap possible. But no ecosystem stays stable forever. Over millions of years, global cooling and shifting seas changed where nutrients concentrated. When prey patterns change, range, the biggest hunters face the biggest challenge: energy. For Megalodon, fossil record studies suggest extinction likely occurred around the Pliocene to Pleistocene boundary, roughly 2.6 million years ago. Livyatan's lineage did not persist in the same form, and later sperm whales followed different ecological paths. What the Pisco Desert preserves is a reminder that even the greatest specialists depend on a stable world. In nature, the long-term winner is rarely the strongest. It's the one most able to adapt. Thanks for watching. If you enjoyed this deep dive into ancient oceans, leave a like, subscribe, and tell me which prehistoric ecosystem we should visit next.